So you're given this function and you're being asked the leading term. What's the leading term? So I'll try to explain by a simple example. If you had like 2x minus 3 times x plus 1, you can FOIL this, right? So 2x times x is 2x squared, and then plus 2x minus 3x minus 3. And then combine like terms, you get 2x squared minus x minus 3. The leading term is when you order your polynomials in the order of the powers, so that it's the powers are decreasing order. The first term is called the leading term. So the leading term is 2x squared. Well, so basically that's what you want to do, but that's just too much, right? Trying to expand this entirely to get the leading term, that's just too much. So we're going to be a little lazier and smarter. Right? Sometimes smart means lazy. Yeah, you know that, right? So
work smarter, not harder.
Yeah, right. Yeah. So what you want to do is you want to write down what that means and see if you can figure out what the answer will be without actually doing the work. Right, so I just wrote down x minus 4 squared is x minus 4 times x minus 4. X squared minus 4 cubed is this times this times this itself by third power. And think about how you can get the highest order. Well, the ones that I underline are the highest order in each of the parentheses, right? Only if you multiply these underlined ones, you're going to get the highest order. If you choose something else, if I choose to multiply this with this, for example, it won't be as high as the order of the polynomial you get by multiplying x by x. Agreed? Okay, so because we're just looking for the leading term, we just multiply all the higher orders. So let's see, what's x times x?
X squared.
What's x squared times x squared? X to the fourth, right? Yeah, x squared times x squared is x to the fourth, right? So it's 4, 6, 8, 10. No. Let's see, x squared, that's 2, 4, 6, 8, 10. Oh, it's 10. Okay, I thought it was 12. Right, it's 10. So you're going to get, if you multiplied everything that's underlined, you're going to get negative 1/8. X to the 10th will be the highest, and then you're going to get other terms if you expand. But that's just too much work. We're not going to do it. It's just something. We don't care. Okay. But then there's negative 1/8. So what do you get? Negative 1/8 x to the 10th plus something, which I don't care. We just want the leading term. Okay. So that's how we work smart, not doing everything. We just looked for this one. Okay. So the answer is negative 1/8 of x to the 10th. Okay. All right. Now let's think about the end behavior. As we have went through yesterday, not yesterday, last class, I explained that if you have a leading term as an even polynomial, then the end behavior is either this or this, right? If it was odd, then it will be either this or that. Okay? So there are like 4 possibilities where the end behavior could be this or this or this or this, but being even, it's either this or this. Okay, because you have negative in front of the leading term, which one is it? Going up or down?
Down.
It's the one going down because it's negative, right? So I know that the end behavior would be going down as you go left and going down as you go right. Okay. C, find x and y-intercepts. Okay. How do you find x-intercepts? How do you find x-intercepts? Set y to 0. I don't see a y. What do I do? Well, the graph is y equals to fx. When we talk about the graph of a function, it's y equals to fx. So, in other words, when we look at this, we really think of this as like y equal to this function. Right? So when we plug in y equal to 0 to get x-intercept, we set y equal to 0. That means we get 0 equals to negative 1/8 x minus 4 squared, x squared minus 4 cubed, x squared plus 4. Okay. Now, when you have a bunch of things multiplied to give you 0, we know that at least one of them has to be 0 in order to get 0. If you multiply a bunch of things that are non-zeros, you never get 0. The only time you get a 0 is when one of them is 0. Right? So either this is 0, which can't be. Is negative 1/8 equal to 0? Never. So that can't be. Or x minus 4 squared is equal to 0. Well, when does this happen?
4.
When x is 4, right? When x is 4, then this is 0. Or x squared minus 4 cubed equal to 0. When does this happen?
2. Right.
Okay, well, all right. So first of all, something cubed equal to 0 means the thing inside the cube must be 0. Okay? But can't you factor this? How do you factor this? X plus 2 times x minus 2, right? So what are the two solutions? X equal to?
Plus minus 2.
Negative 2 or positive 2, right? Okay. And then finally, x squared plus 4 equal to 0. When does this equal to 0?
Wait.
Negative 2
No,
squared is
squared.
positive 4. 4 plus 4 is positive 8. So that's not the answer. When is this equal to 0? No, negative 4 doesn't work either. So no matter what you plug into x, if you square it, what do you get? Something positive. Positive plus positive should be?
More than 0.
More than 0, right? Okay. So the least value x squared could be a 0. But even 0, 0 plus 4 is positive. So is it possible for this to be 0?
No.
No, never. So there's no way this could be 0. So you can't have negative 1/8 equal to 0. That's impossible. That's impossible. The only way that x could be 0 is when x is 4 or negative 2 or 2. So those are the x-intercepts. X equals to 4, 2, negative 2. Okay. Now for the y-intercepts, what do you do?
Set x to 0.
Set x equal to 0. So y-intercepts, you set x equal to 0. Y is negative 1/8, 0 minus 4 squared, 0 squared minus 4 cubed, and then 0 squared plus 4. Okay. Well, this is a very big number. Well, let's see. Negative 4 squared is 16. 16 divided by 8 is 2. So you have negative 2 up for these two. Okay. 4 cubed is 64, but negative cubed is still negative, so it's negative 64. And then times 4. That's 8. 8 times 64 is 512. So that's quite big. The y-intercept is 512. I did this rather quickly, but if you sit down and do the calculation, you'll find that y is indeed 512. Okay? It's not hard, right? It's just long. Yeah, you can do it, right? All right. Okay, now we have to sketch the graph. We have to sketch the graph. Okay, to sketch the graph, we first write down where it should pass. Let's say this is negative 2, that's positive 2, and this is 4. And at 0, it should pass through 512. Now if I made the x and y the same scale, 512 be through the roof, something like 80 feet above our building, so I can't do that. So I'll just squash it and make this, let's say this is 512. Okay, this point is 512. Good? Fine, fine, that's fine, right? Okay. All right, and it has to pass through these 3 points. Also, I know that the end behavior towards outside should be this and this. Okay, so I know that it should be like passing through here and then doing something. Okay. The only thing that I can't be sure of is whether as you pass through these zeros, does it pass through or does it bounce back? So there, we talked about two behavior at the x-intercepts last time, right? So what happens if you have a square for a 0? Does it bounce back or does it pass through? Okay.
Bounce back.
It bounces back, right? In other words, if you have a square or any other even number, then at that 0, it bounces back. Okay. So let me rewrite this. So what you want to do is you want to rewrite this as 1/8 x minus 4 squared. And I explained that x squared minus 4 is x plus 2 times x minus 2, right? And this entire thing is cubed, so each one of them are cubed. X squared plus 4. Okay, so you see that this is which 0 does x minus 2 give you? X equal to? 2. Which 0 does x plus 2 give you? Negative 2, right? Okay, so, and then this one gives you 4. Okay, so 4 comes with the even power, negative 2 comes with odd power, 2 comes with odd power. Got it? Are you with me? Okay, the 2 and negative 2, odd power, 4 is an even power. So let's see. We are going to hit negative 2 because it's an x-intercept. The graph should pass through negative 2. Now, should I pass through or bounce back? Should I pass through or bounce back? Okay, for negative 2, is it an odd power or an even power?
Odd.
Odd. In the case of odd, what do you do? Yeah. Odd, pass through. Even, bounce back. Okay? So at negative 2, we pass through, reach the y-intercept, come back down. At 2, should I pass through or bounce back?
Bounce back.
2.
Pass through.
Pass through. It's odd power, so it's pass through. Okay. Pass through. And now I have to come back to 4 because it has to go through this point too. We know that it has to pass through these 4 points no matter what. Okay? At 4, do I bounce back or pass through?
Bounce back.
I bounce back. So bounce back, and then the end behavior is this, so everything works out. Okay? So that's the graph. Now, if you actually use the graphing calculator, you're going to see something slightly different, which is that at these points, the graph actually touches, it goes and it becomes tangential to the x-axis briefly and then goes up. And that's what happens if you're, so it does this, and that's what happens if your powers are more than 1. So if it was just simply x minus 2 power and it was just the first power, then in that case at 2 it just passes through without showing any kind of changes. But if you have 3 or 5 or 7, any other higher odd numbers, then it does this and goes up. Okay? Yes, you have a question?
So if it's to the power of 10, shouldn't there be like 10, parabolas?
Oh, right. Okay, so
Turning
what?
point.
The question that I just got is the following. Since this is a power of 10, shouldn't I be getting how many turning points? 9. It's up to 9. But that's actually the maximum number of turning points. Okay? That's the maximum number of turning points. And what happens is that the cubed here, those are kind of used to make this dent. And let's see, that squared is used to make this dent. Oh, okay, I see. I mean, possibly there could be just one more turning point. Two more turning points somewhere. It might be like when it goes down, it might be doing this. Over here, it could be doing that. There could be one more turning point. So you can't be 100% sure if this is the correct answer. There might be some more turning points here. That's a good point. Just to reiterate, what I'm trying to say is that if you have degree n polynomial, if the order of a polynomial is n, the maximum number of turning points is n minus 1. Okay? But because that's just the maximum possible one, so there could be some turning points that we didn't count somewhere that's not in the graph. But since it's maximum, it might not be that way. It might be just exactly this. And that part is something that we don't know. So if in the exam you drew this is full credit.